Hi folks, you're very welcome to our open day, and I'm going to outline what we're doing in the Department of Electronics and Mechanical Engineering. So I'm Paddy Hannigan, and I'm in the role of Head of Department for this department. So we have quite a number of CAO programs which I'll get to, but in terms of who the department is and where we fit in within the rest of the college and the institute, we've a relatively recently established Faculty of Engineering and Technology, and what happened under that change, it happened in January of last year. Computing became a part of this faculty. Previous to this, computing was part of science. So now we have computing, Department of Civil Engineering and Department of Electronics and Mechanical Engineering. And that's given us lots of possibilities for future course development. So there's an awful lot of overlap between electronics and mechanical and computing. So these are our CAO programs. So you know how this works. So a level 8 program is an honours degree program. They're 4 years long. Level 7s are 3-year programs, ordinary degree programs. You're welcome, come on down. And level 6 are 2-year programs. Okay, so we have 4 level 8 programs on the CAO handbook now this year. You can see their codes there. LY 608 is our mechanical engineering program. LY 618 is our electronic engineering program. LY 628 is the biomedical, so it's a new program. We don't have it running here at the moment. And then one of these courses that we developed because of this now bigger faculty, the engagement with computing, is we have a computing and mathematics. So we did a lot of the math teaching went on in engineering. Obviously computing teaching went on in computing, and we've put together now a new course, computing and maths, and that's a level 8 program. Then the ordinary degree programs, we have the electronics and mechanical, which are 3 years of the 4-year program that you saw above. And then this year we're running it's currently running, is the first year of it, is our higher certificate in electric vehicle engineering. And as you'd imagine, the electric vehicle engineering has an element of commonality with the mechanical course. And we're doing that in conjunction with Donegal ETB. We're using their facilities, their garage facilities, in order to help us deliver that program. So that's what we have in terms of programs. So I will give you more detail then on each of these programs. There's other things that are driving this. There's obviously a massive move in terms of technology and technology adoption. And one of the drivers for this, we can see, is that there's a national strategy for Industry 4.0. So this is the whole area now about basically automation, smart industry, all of that stuff. So it fits very well with this department. Having electronics, having mechanical engineering, having the electric vehicle, it all fits into that. And you can see what the areas underpinning this Industry 4.0. Cloud computing, advanced sensors, which fits with our electronics program. Automated and autonomous systems, that fits into mechanical, the electronics, and even the electric vehicle is an element of that. Robotics, artificial intelligence, machine learning. These are elements that are part of the maths program as well. Augmented and virtual reality, big element of training now in terms of augmented and virtual reality, that you can do things, you can be trained to do quite dangerous tasks using augmented and virtual reality, much like you had for pilots in the past, where they learned a lot of their learning was done on simulators rather than flying planes initially anyway. Big data obviously fits in with a lot of these areas, the electronics certainly, in the math as well, and then digital fabrication. And you can see a 3D printer out there on the corridor, and you can see technologies, 3D metal printers in our labs. There's a 3D scanner on display today too. So big push for digitalisation in all of this. So these are just some snapshots of elements of activity that are going on throughout the department. So what you have on the left-hand side there is a big CNC machine in the mechanical area. So that's computerized numerical control. So these are cutting devices. These are, there's a plasma cutter down there. These are devices, mills that shape mechanical components. And we get queries from local industry at times for sort of unusual items. So something breaks down on them and they want something and it's not easy got, then it can be built here using CNC machines or printed even with a 3D printer. And then you have the more traditional mechanical skills then on display. These are lathes where they're spinning and cutting items. And then what we had here was, this is a photograph from what we have as an engineering showcase or an engineering expo that's done every year. So every year the students demonstrate their projects to industry. We did it last year in a virtual way using software where you could actually, it was like a virtual environment and you could go around and see what each of the students' projects were. The students had cameras in terms of their laptops, and they could introduce and explain their technology, and you could click on and see videos, and you could see documentation and drawings about their projects. So that's how we've had to change in order to deal with the whole COVID-19 situation. Here you can see these are all outputs really from our electronics and mechanical program. Actually, these are all outputs from first year, right? In first year we have the electronics and mechanical, they do shared modules. We have a module called Introduction to Mechanical Engineering, and really it's to motivate them to the careers in mechanical engineering, and we have an Introduction to Electronic Engineering. So these are 3D printed items on the left hand side. Here we have students demonstrating apps that they developed in order to control the vehicles, and you can see these going on today down in 1128, and then this is a further zoom in on it, and some of the stuff on the computer is in terms of the design side of it. So you can see what they call a breadboard on the top and the connections, but it's Bluetooth controlled, run using your phone. So you all understand technology in terms of our technology being everywhere. You can all understand the applications and the opportunities in terms of technology, and they cut across electronics and mechanical. And we're finding that more and more that the technology is merging. That what we used to do in our mechanical program at one time wouldn't have had programmed elements in it, but that's changing. So you can see how that is changing. And the whole sensor area is bringing electronics more into the mechanical world. So all mechanical devices now have an awful lot of feedback information coming off them. That information is captured by electronic sensors. So we're finding a massive amount of merging in these. So what I have here is reference to additive manufacturing. This is the 3D printing, the computerized numerical control. We talked about the milling machines and the lathes, right? So the milling machines are just elements of cutting, and the lathes are the turning rotation. A lot of equipment or a lot of parts are based around cylinders and things that are created by turning. So that's Internet of Things. Then is the whole sensor area and how technology is moving on. So you'll see down in the labs an Alexa, and the Alexa is programmed to do lots of things. The Alexa is programmed actually to move one of those vehicles on the floor, so you can tell the vehicle to turn left, turn right, and that's been done through so that's Internet of Things, where everything, smart homes is another way of looking at that, and advanced sensors. Now again, Internet of Things is going to be everywhere, not just in homes, it's industry as well. So it's research informed teaching. So we have research centres associated with our department. So there's the Wiser Technology Gateway is an Enterprise Ireland funded centre, and what was done in the Wiser Technology Gateway is companies come in with particular challenges that they have, new product development, and they want support, and they get support in this Wireless Sensors Applied Research Centre here on campus, and that's a national centre. So then we have a Bryden Centre that's named after an academic who was from University of Highlands and Islands, who unfortunately passed away. But it's a renewable energy research centre that we're working with the University of Highlands of Islands, Queen's University Belfast are very heavily involved, Ulster University are involved, and we're involved. And that's interesting research in terms of renewable energy, looking at tidal energy, looking at wind energy, looking at wave energy, and looking at other types of energy sources. So that's an interesting project, and that's been running for a while. The Northwest Centre for Advanced Manufacture, again in the mechanical area, and our partners with that are Ulster University. These are all funded projects from European money. And then we're now working with University of Ulster at Magee in data analytics, artificial intelligence. And they have quite a lot of interest there in terms of the data analytics world. So that's a good match for us as well. So that's just normal activity, and hopefully we're heading back for more normal activity in the future. So here is our B-Eng in electronic engineering. So I just set out the first year of these programs because it's a relatively short talk. There's a lot of detail when you go across 4 years of a program. So here we have, what we would expect in an engineering program: mathematics, engineering, science, which is basically applied physics. Then the two modules I'm talking to you about: introduction to mechanical, introduction to electronics, and then digital fundamentals. So that's really on the logic of programming and devices that you can program. The same ideas then are followed into the second year, second semester, a programming module. This is in order for them to control microcontrollers. Then we have electronics module, another math module, electrical technology, because the whole electrical world is important. And that last module is PLC. That's programmable logical controllers. And that's got to do with the whole world of automation. So that's our first year in our level 8 program in electronics. And this is our mechanical engineering program. So you see quite a number of the elements are similar. There's an engineering technology and drawing there, which is separate, different, and that's where the students get the experience in the workshop. So now that those of you that are here on campus should go and see the workshop that we had photographs of earlier. And then that's followed through then into the second semester with an engineering technology and drawing 2. And you can see then a lot of the things are common. The PLCs again here, because automation is as important in mechanical as it is in electronics. And you can see the mechanics element coming through there. This is the Biomedical Engineering program. This is the new program that will be starting to offer from September 22. Again, a number of elements are common because they have to be. They're important elements. And you can see then biomechanics and chemistry appearing then to support the biomedical applications. But big focus in terms of the biomedical program is in terms of sensors and the electronic side of things. So into the second semester, you can see the introduction to anatomy. I was going to say autonomy. Introduction to anatomy and physiology. So then, this is a new program now that we're starting to develop, and I was saying it's coming out of that collaboration or this new faculty of engineering and technology, and having computing as part of our. So we have this has been put together now as a course. This program is 50% computing, 50% maths. We went and we designed it with the Teaching Council's criteria in mind, so that we would cover enough mathematics, enough computing, so that a graduate could become a teacher in either or both. So the essential mathematics is a big module, 10 credits in the first semester, then programming, and then into the second semester you start to see the math element grow, and there's an essential mathematics 2, a statistics 1, and then object-oriented program, and it builds through applications of math. So it's quite an applied program as well. You'll have good career opportunities out of that program. So these then are just the reference to the level 7s. We have the level 7 B-Eng in electronic engineering. It is the same first year as the honours program, but is a 3-year program, and the mechanical again has the same first year as the level 8 mechanical, the equivalent level 8 mechanical. And then just the level 6 that we have just started here this year. So this is our level 6 electric vehicle engineering. So it's a new program. It wasn't included in the CAO handbook last year. We took a bit of a punt on it in terms of offering it really where students can only choose to do it through vacant places. So we were able to get the program up and running. So this year's the first year now that we're having it, running it through the CAO handbook. So we run a night class as well for qualified mechanics in electric vehicle engineering, and we're learning a great deal from that. So that's been a useful thing to do. So this is the higher certificate in electric vehicle engineering. Again, quite a number of common elements with the mechanical, as you would expect. We have an automotive components and drawing one, a 10 credit module, and we, as I was saying, we use the facilities in Donegal ETB, which is just out here in Ballyreen, as part of that. And you can see that's followed through then with 2 modules then in the second semester. We have an electric vehicle low voltage and high voltage systems and an automotive components and drawing. So this was just broadly future developments. So what I've got there is a sketch of an extension that's going to go on to the college in that direction. So the campus development, there's more coming. We have started electrical apprentices. My sentence isn't the best there, but it started in September 2021. So that's been an increase, a change, and we're hopefully get into more apprentice areas in the future. And then course development, as we've started off with this Industry 4.0, that'll be a big focus for us. So maybe into the areas of advanced manufacturing and that type of territory. So this was the Institute generally, to be a leader in higher education opportunities and challenges posed by the emerging disruptive technologies. That really is, that's part of our vision statement. So that really falls to this faculty. This faculty, engineering technology, has a big focus on that. And then the other things are obviously the movement towards the technological university that you'll know that we're doing with IT Sligo and GMIT. So, you know, we're hearing news about that all the time. We think it's probably likely to be the start of March, but we've no, it'll be early in the new year for certain. And then this is then obviously what we've been doing in terms of the research centre, is the development of the Northwest region through research, innovation and enterprise. So it's not just the education side of things. Okay, that's the end of my talk. Any questions from you? No? Well, any of you that want to come and see, haven't seen some of the facilities, want to see the 3D scanner, want to see what the electronics, what we're doing in electronics, or see the CNC equipment down in the mechanical workshops, or I can do that. We can talk about that after. Okay, thank you.